Some Fiat and Lancia models are currently changing from the traditional carburetor intake to the latest electronic fuel injection system. There are many advantages in this development. More efficient use of fuel, which leads to greater economy, a marked reduction in harmful emissions, and greater torque at low engine speeds. Electronic fuel injection means simpler service and maintenance for you. All this with improved performance and flexibility, a major factor with Fiat and Lancia drivers. The L-Jetronic system is controlled by the airflow. The L stands for Luft, the German for air. Like all fuel intake systems, L-Jetronic is designed to ensure the optimum air-fuel mix for proper ignition and combustion. This is 14 parts of air to 1 of fuel. The 3 major systems in L-Jetronic are shown here. Red shows the fuel system. Blue shows the air system. And green shows the electrical system. The L-Jetronic system calculates the exact amount of fuel required by the engine and then sprays that quantity in front of the intake valves in a very fine mist. The system atomizes fuel better than an ordinary carburetor. The minute droplets mix more readily with the intake air, giving greater economy and cleaner combustion. The fuel metering system keeps the 14:1 air-fuel ratio correct for perfect combustion at all times and under all operating and ambient conditions, except start and warm-up. The air is distributed to each cylinder by manifold ducts of equal length. Unlike conventional carburetors, which use venturi restriction to draw fuel into the airflow by vacuum, the fuel injection system is free of airflow restrictions, except for the throttle plate. The freer airflow improves cylinder filling, especially under low airspeed conditions, such as idling. In cold weather, carburetor systems suffer from fuel condensation on the inside of the manifold. But in L-Jetronic, only air travels in the intake system. The fuel is injected just ahead of the intake valves and passes directly to the cylinder. The air bubbles and vapor locks, which can develop in carburetor systems, do not occur with fuel injection, as the fuel is held at a constant pressure throughout. The Bosch L-Jetronic has been chosen because it offers extreme sophistication in its function while remaining fairly simple in design and highly reliable in operation. The fuel supply system starts with fuel being drawn from the tank and pumped through a filter to the pressure regulator, which maintains the correct pressure throughout the whole system. Fuel is then supplied to each injector. Fuel is also supplied to the cold start valve, which is positioned in the intake duct to supply extra fuel during cold starting. The fuel pump has a DC motor and is constantly filled with fuel for lubrication. Should the tank be emptied by a forgetful driver, the pump still remains primed. The pump always delivers more fuel than is required. This prevents the formation of vapor bubbles. Excess fuel flows back to the tank. The fuel filter prevents any harmful particles of dirt from reaching the injectors, since any impurity could disrupt spray action or ruin machine surfaces. Invariably, the filter and pump are fitted close together. Here they're on the Argenta. Both are sealed units. The fuel flows under pressure from the filter to the injectors, which are fitted in the manifold in front of each inlet valve. The injector has a nozzle which is activated by a solenoid. When the solenoid is powered, the armature draws back, lifting the nozzle from its seat and opening the channel for the fuel to spray out. The injectors are easily recognizable on the intake manifold. If they fail, they must be replaced. A metered quantity of atomized fuel, the right amount of fuel, is waiting to be drawn into each cylinder. Half the fuel is sprayed ahead of the inlet valve. On the next rotation, the second half of the fuel. The inlet valve opens and the mixture is drawn in. The amount of fuel injected on each cycle depends on the length of time the nozzles are held open. This in turn is regulated by the electronic control unit. In fact, the nozzles are held open for a fraction of the time of a photographic flash. The fuel pressure regulator ensures that the pressure throughout the system is correct for all conditions. Without a regulator in the system, the amount of fuel injected could vary with the relative strength or weakness of the vacuum in the intake duct. If the vacuum were low, less fuel would be drawn through the open injector, and there would be more fuel if the vacuum were high. But with the fuel pressure regulator, changing vacuum levels are compensated for, and the pressure differential at the injector is virtually constant in all conditions. The fuel pressure regulator is open most of the time to allow excess fuel to flow back to the tank. This also has the benefit of lowering the temperature of the fuel supply. The pressure regulator is divided into two chambers by a spring-loaded diaphragm. A vacuum line connects the vacuum chamber to the intake manifold. At rest, the diaphragm is held against the fuel outlet by the spring. As the fuel pressure builds, it acts against the spring, opening the outlet port. The vacuum signal acts on the diaphragm constantly, changing the amount of fuel that is released through the outlet port. This maintains the pressure differential at the injectors. The fuel pressure regulator is normally on the injector piping, as it is here on the gamma. As no adjustments are possible, it must be replaced if faulty. Cold starting is assisted by the cold start valve. It only functions when the starter is cranking and the Thermo time switch in the cooling circuit is closed. Its job is to enrich the mixture. It's located in the intake manifold, downstream from the throttle, and operates in cold starting conditions. The solenoid pulls up the armature, opening the swirl nozzle, allowing in the additional atomized fuel until the engine is warm. The nozzle then closes. The cold start valve is easily located on the intake manifold and is another replacement-only item. That completes the fuel system. The fuel is pumped through the filter to the injectors under pressure, controlled by the pressure regulator. The cold start valve operates when the engine is After leaving the air filter, the air passes through the airflow sensor. This is the heart of the L-Jetronic system, and it is located before the throttle plate. It measures the amount of air taken in at any engine speed or load. There is a supplementary air valve for bypassing the throttle plate during warm-up, allowing an additional amount of air to flow in. Tapped into the intake manifold is the vacuum signal line for the fuel pressure regulator, which was covered in the last section. The amount of air allowed into the intake is measured by the airflow sensor, and the system is called airflow control. The function of the airflow sensor is to produce a voltage signal in direct proportion to the amount of air drawn into the engine, and it contains both mechanical and electrical components. The mechanical part is made up from the sensor flap, compensating flap, return spring and bypass channel. The backfire valve, where fitted, is on the sensor flap. The bypass channel has a carbon monoxide adjustment screw. As air is drawn into the engine, the sensor flap is opened against the return spring, and as the compensator flap is moved into the damping chamber, it steadies the movement of the sensor flap, minimizing possible back pressure oscillations. When the accelerator is depressed, the throttle plate opens, allowing more air into the intake manifold. The amount of air passing over the airflow sensor flap changes its position. The greater the amount of air, the greater the flap angle. At idle speed, the flap is nearly closed, opening as part and full throttle is achieved. The shaft of the sensor flap is attached to a potentiometer, which, according to its position, transmits a varying voltage to the sensor flap, indicates the amount of air to the electronic control unit, which then computes the correct fuel flow. The potentiometer is also connected to the fuel pump, so that it functions as soon as air flows through the intake manifold when the engine turns. The unmistakable shape of the airflow sensor makes it easy to locate in any model. The only adjustment to be made in this area is for CO level. The adjustment screw controls the airflow in the sensor bypass channel, and it is fitted with a tamper-proof plug. Another aid to starting and warm-up is the supplementary air valve. It provides extra air at this time. Its function is to control the flow of air through the bypass around the throttle plate, providing extra air during cold starts and warm-up. The electronic control unit responds to the additional air by metering more fuel to the engine, thus raising the idling speed. The valve contains a blocking plate or shutter. Cold, the bypass channel is open, being unobstructed by the blocking plate. This allows a free flow of additional air to pass through. As the engine warms up, the bimetallic strip bends and allows the blocking plate to move, so closing the bypass channel progressively. Once the engine is up to temperature, the bypass channel is completely closed. The supplementary air valve is found in different places on various models. In the Argenta, it is on the cam housing, as it is on the HPE. On the Gamma, it is on the right-hand manifold. No adjustment can be made to the supplementary air valve. Idling speed is adjusted when the engine is hot by the idling adjustment screw. This is placed on the butterfly bypass, as in a conventional carburetor system. Some automatic models have a fast idle valve linked into the system. A solenoid activates the valve, which allows in additional air to step up the idle speed. The fast idle valve has an adjustment screw. Here it is on the Trevi. There are only a few components in the air system, but the airflow sensor is the key to the whole operation. From the air filter, the air flows to the airflow sensor, which measures it, thus regulating the fuel supply via the electronic control unit. Cold starts are aided by the supplementary air valve, and idle speeds adjusted by the idle adjustment screw. The vacuum source for the fuel pressure regulator is also part of the air system. If the L-Jetronic's heart is the airflow sensor, its brain is the electronic control unit. This is powered by the car's battery through the ignition switch and relay. It receives signals from the ignition coil, airflow sensor, throttle plate switch, air temperature sensor, coolant temperature sensor, supplementary air valve, Thermo time switch, and ignition switch cranking position. All these inputs are computed to provide a correct output signal to the injectors and the cold start valve. The electrics of the L-Jetronic receive their power from the battery via the relay, which is made up of the power relay and the fuel pump relay. The power relay supplies power to the control unit, the injectors, and the fuel pump contacts in the airflow sensor. The fuel pump relay supplies power to the fuel pump itself and the heating element in the supplementary air valve. These are the connections with the ignition switch on, during starting, and while the engine is running. The electronic control unit accepts inputs from all parts of the system. It evaluates them and sends the correct output signals to the injectors. The inputs include the information from the potentiometer in the airflow sensor, metering the exact amount of air flowing through the intake manifold, the temperature of this air, the temperature of the coolant, and the exact position of the throttle plate. There is also an input from the ignition system, which indicates engine speed. A multi-pin connector and wiring harness connects the electrical part of the system to the electronic control unit. The injectors are wired in parallel, and the injection pulses reach each injector simultaneously, injecting half the amount of atomized fuel on each rotation of the crankshaft. The unit contains some 80 components, which include 3 integrated circuits. It is capable of controlling the opening time of the injectors from 3 to 9 milliseconds, depending on the engine's requirements for optimum performance. Like many components in L-Jetronic, it must be replaced if defective. The electronic control unit is invariably sited under the dashboard. The coolant temperature sensor provides the electronic control unit with information to provide extra fuel during warm-up. This enrichment must be progressively reduced as the engine temperature rises, and cuts off completely when it reaches normal. The resistor in the sensor has a negative temperature coefficient, usually referred to as NTC. This means that as the temperature rises, the resistance of the sensor decreases, allowing a stronger current to flow. At -10 degrees centigrade, the resistance will range from 7,000 to 11,600 ohms, while at 80 degrees centigrade, the resistance drops to 390 ohms. Here it is on the Argenta. The throttle valve switch is attached to the throttle housing and is operated by the butterfly spindle. It signals to the electronic controller the throttle position from idle through to fully open. Within the switch are two fixed contacts and a third movable one. In this position, the signal to the control unit is that the butterfly is closed. Depending on engine speed, the control unit will translate this signal in one of two ways. If the engine is at idling speed, it will slightly prolong the injection period to enrich the idling mixture. If, however, the engine is decelerating from above 1600 RPM, then the instruction will be to cut injection completely until the revs drop down to 1200 RPM. This results in a fuel saving and a reduction in exhaust emissions. If the engine speed is below 1600 RPM when deceleration starts, injection is not cut off, but continues normally down to idling speed. In this position, the signal is that the butterfly is fully open, and again slight enrichment is given for full throttle running. The throttle switch is easily identified on the side of the butterfly assembly. Air temperature in the air intake is also fed to the electronic controller. The sensor is mounted so that it protrudes into the intake airstream. Like the coolant temperature sensor, it has a negative temperature coefficient. Its electrical resistance decreases as the temperature increases. The controller uses the information received on intake air temperature to adjust the injector open time to compensate for cold air. As air temperature rises, so enrichment is lessened, and should it exceed 40 degrees centigrade, it will cease altogether. Both the cold start valve and the Thermo time switch circuits form part of the electrical system. The operation of the cold start valve was covered in the fuel system section. To remind you, it is controlled by the Thermo time switch, which is placed where it can sense the coolant temperature. Above 35 degrees centigrade, there's no need for the cold start valve to operate. But below that temperature, it opens and injects additional fuel into the intake manifold. The signal that motivates the cold start valve comes from the Thermo time switch. This contains a bimetallic strip which warms up quickly on starting, so that the signal to the cold start valve isn't too prolonged. In this way, the maximum length of time the cold start valve can remain open, even at minus 20 degrees centigrade, is 8 seconds, so there's no danger of the engine flooding. Here it is on the Argenta, under the inlet manifold, and on the coupe. The brain of the L-Jetronic system is the electronic controller, which receives power from the battery via the ignition switch and relay. It receives signals from the airflow sensor and throttle plate switch, coolant and air temperature sensors, and the ignition system. Having computed the information from these signals, the electronic controller provides the output signals for the correct start and duration of injection. The relay also provides power for the fuel pump, supplementary air regulator, the cold start valve, and the Thermo time switch circuit. L-Jetronic is a most reliable system, and should the engine not start or not run properly, be certain to make the usual checks first. The battery and electrical connections, valve timing and clearances, plugs, compressions, and ignition timing. Only if the problem is still there should you check the fuel injection system. You only need an avometer and a simple fuel pressure gauge reading up to 6 bars. A 12-volt test light can be used for some tests in place of the avometer. The strictest fire precautions must be observed at all times when servicing or doing diagnostic work on a fuel injection system. Atomized fuel leaves the injectors at 3 bars. No smoking, of course. Place each injector in a suitable glass container and remove the high-tension cable from the coil. This way you won't be taken unawares by an ignition spark. Before dismantling the fuel system, go over the complete air system for any leaks. All air entering the system must pass through the air sensor so that it is properly metered. Leaks after the air sensor will lead to a lean mixture. Check all the ancillary piping as well as the trunking from the air cleaner to the airflow sensor and on to the throttle chamber. Now start your check of the fuel supply system to see if the pump is working and giving 3 bars pressure and that the filter is not restricting the fuel flow. A number of checks are covered by removing the injectors. The best place to fit the fuel pressure gauge is by the cold start injector. As the fuel line is broken, petrol under 3 bars pressure is released. Place the injectors in their glass jars. Switch on the ignition and move the air sensor plate from its rest position to check the pump. In one move, you have checked the pump circuit, the relay, the contacts within the airflow sensor, the fuses, and the pump earthing. The pressure reading should be 3 bars, plus or minus 0.2. Now release the airflow sensor flap and the pump will stop, but some pressure will be maintained in the system. If the fall is greater, check the injectors for leaks. There should be no more than 2 drops per minute from each one. Next, check the pressure regulator by clamping the fuel return pipe and operating the air sensor flap. As the fuel can't return, you are checking what pressure the pump can produce. The gauge will go to maximum. The injectors should hold this pressure so the fault doesn't lie there. On releasing the clamp, the gauge shouldn't drop below 2 bars. If it does, the regulator is faulty. The next check should be the cold start valve. Make sure the HT connection on the coil is still removed so there can be no sparks while the engine is cranking. As a safety precaution, hold the injector into a glass jar. With the engine cranking, you will see a spray of fuel for a set length of time, depending on the engine temperature. A cold engine in a normal workshop should give a spray of 3 to 4 seconds, but check in your manual for correct timings. By now, you have checked the operation of the Thermo time switch too. With all this engine cranking, the glass containers should all hold some fuel. If you have a dry one, it means that there is a faulty injector which must be replaced. The fuel system has now been completely checked and can be reassembled. Give the air trunking connections a final check. Before removing the multi-pin plug from the control unit, take the ignition key out. The control unit can be seriously damaged if the ignition key is switched on while disconnecting. Most of the electrical checks can be done from the multi-pin plug. Holding it in your left hand, the top line of contacts are numbered from 1 to 18 and the bottom line from 19 to 35. If the coolant temperature sensor is malfunctioning, the wrong mixture will be provided, leading to uneven running and high fuel consumption. Set the avometer to ohms. Put one lead on terminal 13, the other being on earth. Refer to your manual for the correct resistance. While you're on the ohms scale, put the leads on terminals 6 and 8 to check the airflow meter. Your manual gives the right resistance. Complete the airflow sensor check by checking terminals 7 and 8, and then 8 and 9. Using the avometer as a voltmeter, you can check that the control unit is getting the correct 12 volt. Ignition on. Your workshop manual gives you all the details you require for checking ohms and volts, as well as the use of the test light on the rest of the system. Make sure that the ignition key is again out before you replace the multi-pin connector. With the engine cold, the revs should drop away when the air pipe is clamped. If they don't, the supplementary air valve is faulty and must be replaced. If the engine is hot, the speed should remain constant after clamping the air pipe. If it drops, first check that there is an electrical feed to the valve. If there is, then the valve itself is faulty. Once the engine is up to temperature, that is, when the thermoelectric fan starts cutting in and out, you can set the idle speed. The workshop manual gives the correct details for each model, and the adjustment is made by the idle screw in the normal way. Go on to check the CO level using the CO adjustment screw on the airflow sensor. Make sure you replace the tamper-proof plug once the correct setting has been achieved. On automatic cars, there is sometimes an adjustment to the specially fitted fast idle valve. Your workshop manual gives all the details in the servicing section. You will find